Hello everybody. These are the notes for Calculus, section 3.5. What we've been talking about in section 3.4 was the process and the definition of finding a derivative. That's the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, that derivative function is the function that gives us the slope of a tangent line at a certain x value. All right, this is also the instantaneous rate of change and all that stuff. But for what we're doing today, trying to graph the derivative function, that's what we want to concentrate on. Is the derivative gives us the slope of the tangent line. Okay, so like it says here in number 1, what we really want to do is kind of switch that around. We're going to be given a graph of a function, but we want to be able to graph the derivative. And so the y values for that derivative function at a certain x value, the y values of the derivative functions are the slopes of the tangent lines. And so if the slope of the tangent line at a certain x value is a -3, the -3 becomes the y value for that derivative graph. Okay, so I'll come back to this slide, but I want to go to this. All right, so what we have is just a generic function. Okay, you see these orange dots here, and these are just certain x values, and that's the whole idea. You're just going to go one x value at a time. So these orange dots slide up and down. So we're changing the y value, but at the same time, it's changing the slope of that orange line. Now, the derivative is the slope of a tangent line. So I'm going to move this orange dot to a y value until the slope of the tangent line is, until the slope of that orange line is a tangent line. I'm going to go to the next x value, move that until it's a tangent line. So I move that orange point to a certain y value where it's a tangent line. So the slope of the tangent line is the y value. So this tangent line has a slope of -12 because that's the y value of that orange point. Now here, it's a relative minimum. Slope should be 0. It's a horizontal line there. Go to the next point, same thing. Go to the next point. Now we're down here. Negative slope again, so we got a negative y value for our tangent function, or sorry, for our derivative function. And move this. It's a steeper line, steeper tangent line, so it's a larger negative slope. So our y value is larger negative. And the last one, this is going to be even steeper for a tangent line, so it's going to be even more negative. Okay, that orange graph that just popped up, that is the graph of the derivative. The y values of that derivative graph are the slopes of the tangent lines at those certain x values. And I can click on check answer and correct. Hooray. This is the idea here. Now, if you want to mess with this applet thing that I just did, I put a link onto my website, so you can mess with it on your own. You click on next question, and it'll change the function, and you can just try it again and see the connection between those y values and getting the derivative. So here's the next graph. You could go do your own. All right, so to graph a derivative function, the y values of the derivative function are the values of the slope of the tangent line at a certain x value. When you are given a graph, what you want to start with is number 2. At any relative minimum or a relative maximum, the tangent line has a slope of 0. So if we're looking at this kind of graph, the tangent line at this relative maximum, it's horizontal. It has a slope of 0. And so at that x value, the derivative graph would be crossing the x-axis. It would be a y value of 0. At this relative minimum here, slope of this tangent line is 0. So at that x value, the y value of the derivative graph is going to be 0. And so now, like we talked about in the second part of section 4, is when does a derivative exist? And so in order for a derivative to exist, the graph has to be a smooth curve. Okay, this function that I've graphed here, it is a smooth curve. the derivative function is also going to be a smooth curve. It's going to kind of follow along with the same kind of, curviness. Well, that's a terrible word, but if our graph is a smooth curve, the derivative graph is going to be a smooth curve. So the rest of this derivative, you start looking at the slopes of the tangent lines. Around here, there's a tangent line. It is a very positive slope, but as we move along, the slope becomes less positive. It's still a positive slope, but it's moving closer to that horizontal 0. So the derivative, it started out positive, went down to 0. Okay, as we move past this point here, where that relative minimum, our slope of the tangent line turns negative. And so it's not very negative, it's a little bit negative, but it's in the negative region. So the slope of the tangent line becomes the y values for the derivative function. But eventually, that slope of the tangent line goes back up to 0 here, and in all these spots, the tangent line has a positive slope. So here is our derivative graph in blue. This would be f prime of x. This is the idea of what we're doing. Okay? It's not an exact science. You're not going to get perfect graphs. You're just estimating the slopes of those tangent lines, which means you're estimating the y values of the derivative function. And so you should get a same general shape, but again, concentrate on these points. Those relative mins and maxes for the function, the derivative is going to be equal, the derivative y value will be 0. So it's crossing the x-axis there. Okay. So this is the idea. It takes a little bit of practice. If this is our function here, I'm going to start right there. There is a minimum for this graph. So the slope of this tangent line is 0. So at this x value, our derivative graph is going to be 0. Now, all these tangent lines here, they have a negative slope. Once we get to this spot, those become a positive slope. So, just going to kind of estimate it. The further over we go in the negative x direction, the steeper this graph gets, so the more negative the slope of the tangent lines are going to be. So what we're looking at is going to here, they were negative, the slopes of the tangent lines were negative, but going towards 0, and then they become positive, and they keep on getting steeper. So these y values keep on going up. Okay, this would be the graph of the derivative. So this is it. This is what we're doing. It's not an exact science, but that connection of the slope of the tangent line, that number becomes the y value for the derivative graph. All right, that's it.